So improved farmhouse design. Whenever we talk about any farmhouse or whenever we come across any farmhouse, we see that in general or very commonly the design of the farmhouse are very fantastic. It looks pleasant, it looks beautiful. At the same time, it also provides comfort and basic amenities. So why it is required? Because farmhouse is not only used for cultivation of crops, but very oftenly it is used for relaxing, enjoyment, family gatherings, etc. That's why we talk about improved farmhouse design. So a farmhouse should be designed to provide maximum utility and comfort. So it should be designed in such a way that it should provide maximum utility and comfort for the people who are going to reside in that area. Also, it should be designed in such a way that each and every activity, like individual activity, should or process should contribute towards the second activity. It shouldn't be in such a way that one activity is damaging some activities of the second process. Like say, within the farmhouse, we have dairy unit, we have poultry, we have goatry, we have fisheries unit, as well as many more components can be added within the farmhouse. Also, within the farmhouse, we have farmstead area, which consists of residential area too. So, the design of farmhouse should be in such a way that neither the crop cultivation should hamper some activities of livestock rearing, nor the activities of livestock rearing should hamper the activities of crop cultivation. Neither these two activities should hamper the comfort level of the people who are residing in the farmstead or the residential building. Also, it should be designed in such a way that being in the residential area, the owner should have access to visualize, to monitor each and every activities being at their residence area itself. Therefore, we talk about house design or farmhouse design that should be improved on. So, a farmhouse should be designed to provide maximum utility and comfort. The various rooms should be so located as to provide adequate comfort and minimum time and energy wastage in going from one to the other. So uh, we should consider three or four points that farmhouse should be designed in such a way that it should provide maximum utility and comfort for the residents. Also, the various rooms should be located or it should be designed and constructed in such a way that minimum time and energy must be utilized for going from one room to another room or from one place to another place. So easy access should be there to all the rooms and all the components. So that is we talk in the improved design of farmhouses. So talking about bedroom, a typical bedroom of 3.6 into 3 meter will accommodate two single beds of 1 into 2 meter. Cross ventilation with one side exposed to the prevailing breeze is a desirable feature in design. Every bedroom should be provided with attached toilet facilities or should have an independent access to the common toilet room. Some storage space is also essential in every bedroom. because the residents or the people who are going to stay in that area, in that bedroom, very commonly they have their own personal belongings and which has to be stored or which has to be or proper space for uh, keeping or storing that all items should be provided in each and every bedroom. Additionally, there should be proper arrangement of ventilation and cross ventilation. So in each and every room, especially in bedroom and drawing rooms, cross ventilation is must. If there is no proper cross ventilation, it is going to be the atmosphere is going to be say like dizzy or very uncomfortable for the people who are going to stay in that room. So therefore we talk about whenever we talk about a bedroom, there is a typical size. Smaller than that size, we should not construct the bedroom for accommodating two people or two beds. And we also talk about the cross ventilation. That cross ventilation is must in every bedroom. So this can be one of the design of the bedrooms and several other rooms. Like we can see the entry is from here. This part is veranda consisting of 3.9 meter into 1.90 meter. Then there is an entry, first entry towards the bedroom, and the size of the bedroom is 4.0 into 2.8 meter. Second entry is in the living room. Then from the living room there is entry to the dining veranda or the dining space. Similar kind of space or opening is attachment is given from the bedroom or access is given from the bedroom to the dining veranda. So the people staying here as well as here can have access, direct access to the dining area. Similarly, you can see like this bedroom is attached with a storeroom also. Also, there is a passage or opening. Bathroom is here, and then this one is the kitchen area. So by this design, some calculations are also given. Like main block is 12.8 into 4.6 meter, that is 59 square meter. Then side is 6.7 into 3 meter, that is 20 square meter, and all total it is 79 square meter. Then deduction 1 into 2.1 meter, that is 2 approx 2 square meter. So when we subtract from 2 square meter from 79 square meter, it is going to be 77 square meter. So 77 square kilometer, 77 square meter of area constructed or design is for 77 square meter. So we can see that uh, this design is very comfortable. It is very it will this type of design if we have in the farmhouse for the residential area for residential building, it is going to provide the maximum comfort, as well as you can see that there is opening over here veranda, there is passage and opening over here. The toilet facility is provided at the end. So this is a very good kind of design, and from the both side there is opening, so cross ventilation will be proper in this type of design. Next is the drawing room. So drawing room, as we know that it is for social gathering, recreation for the guests who are visiting. We take them to the drawing room rather than taking them to the bedroom or to the dining area. So the drawing room generally serves as the room for recreation and social gathering. The minimum size of the drawing room is 4.5 into 3.6 meter. The minimum size of the drawing room, that should be 4.5 to into 3.6 meter. But some people prefer to have one large drawing room of about 6 into 4.5 meter to serve as the drawing cum dining room. There are people who wish or they prefer to have a bigger area of drawing room. So combinedly, they can use that drawing room for uh, social gathering, recreation purpose, or for visiting of the guest, as well as dining room or dining facilities are also provided within that drawing room itself. So that depends on the choice of the owner that what size of drawing room he or she requires to be constructed. So the drawing room is best suited to be on one side of the house and should generally open into the front porch, kitchen, and one side should be the bedroom. So remember this, the drawing room is best suited to be on one side of the house and should generally open into the front porch, kitchen, and bedroom. Then wall spacing in the drawing room should have plenty of provision for natural light and ventilation. So the wall space in the drawing room should have plenty of provisions for natural light and ventilation. Earlier also I have discussed that the residential building should have proper cross ventilation facilities as well as natural light. So it has advantage whenever there will be in such room where there will be proper ventilation and flow of air, circulation of air, less say like fan or AC facilities will be required. Coming to the site selection, we should pay attention to the following points when site is going to be selected. We should clearly identify the type of soil, the soil depth, and fertility level of that soil, because these are the important points. Or whatever cultivation, soil is a very important. Depending on the soil type, all the living and non-living activities will be decided, or the cost will be decided. How? I'll explain. Suppose for the living components like cultivation of crops, orchard, plants, fruit, trees, this all plants cannot be grown in all type of soil. Several There are specific crops which can only be grown in a specific type of soil. Then soil depth of the topsoil or fertile soil is also required. Depending on this type, depth of the soil only, we are going to decide that what crops or what tree are to be cultivated or planted in that area. Then fertility or level of fertilizer, or say like humus or quality of soil, is a very important factor in determining or deciding the crop which has to be cultivated. Secondly, if we talk about the non-living component, say like building area, the type of soil or depth of soil decides that how that building has to be constructed. Say like if it is a sandy soil and the topsoil is the depth of topsoil is say like 2 to 2 meters approx. While constructing any building, we should we must dig very deep, and all the basement work has to be done very nicely and with huge investment, then only our building will stand properly and will stay for several years. Additionally, if our soil is, say, like sandy soil stabilization work has to be done before constructing any building of, say, like 2 floors, 3 floors, or a big building. So for stabilizing the soil, it will require additional amount. So that is why for site selection we should consider the soil type, soil depth, fertility level, drainage of the soil. So drainage of the soil is another important factor, and this is related to cultivation of crops. Availability of water. Availability of water is the most one of the most important parameter which should be considered while selection of any site, because depending on the availability of water, we will decide what all crops or what all activities has to be done in that area. Then the natural vegetation, that will be also very helpful, and access to the area. How much far is from the main city, or what is the connectivity to the roads, as well as communication and several other functions. So these are the points which are very important, and this has to be considered while selection of any site. So next comes the farm layout. So a farm layout refers to the compiling of physical structures such as homesteads, outbuildings, waterways, contours, camps, water supply roads, and layout of orchards, vineyard, or lands. So we can see that whenever we are like at the planning stage, we go for site selection, several parameters we consider, then we go for farm layout once our site is selected. So within that farm layout, we draw on the map that what all facilities and what all constructions has to be done within the farm area, as well as we allocate the land, that our farmstead, our residential building will be here, cattle shed will be here, goatry unit will be here, water pond or fish pond will be here, or harvesting pond will be here. So this all things comes under farm layout. So a layout of modern farmstead, this picture can be a very good example of layout of the modern farmstead. So in this picture, you can see that the farmstead is not in the center point, but it is in the corner near to the road, say like near to the road or in the corner. So it has some advantage as well as some disadvantages. So you can see that this area as well as this area are used for cultivation of some crops, as well as this area is for agroforestry, whereas this boundary area, there are several trees, and I think these trees can be of fruit trees. You can also see that uh, this there is difference between this one and this area. So there are different crops which are cultivated in this area. See, there is some boundary at this place, there is some boundary with the trees, so it has some advantage. Like in this type, in this within this type of field, we can cultivate such crops which are very say like vulnerable to high winds, or during the windy seasons we can cultivate some crops which are say like flower crops, or uh, which are very say like vulnerable to high winds. So this type of natural structures are made, and this is the water body, and I think it is in the lower elevation zone, so all this water, excess water, will drain out and it can be collected, and this area can be utilized for fish cultivation as well as for storage of rainwater, and later in the dry season this water can be utilized for irrigation as well as for other purposes. So this one is one of the another view or image for modern farmstead. So you can see, I think this one is this farmstead is situated at the center point of the farm. Like you can see, around this farmstead there is cultivation of crops, and within this given area, water harvesting pond, fish pond, as well as biogas plant. This can be the dairy shed or animal shed. Somewhere here will be the residential area, and this all are similar buildings. I think this one is also some kind of livestock building, say like for dairy unit, etc. So you can see the designing of the uh, say like the designing of the farmstead depends on several factors. You can see from this image it is very clear that somewhere at this location is at higher elevation and this side it is lower elevation. So at the lowest point they have constructed the fish pond. So this fish pond can be utilized for two or three purposes. One is for rainwater harvesting, storage of water. In the same water we can go for fishing. Then this water will the collection of water and storing here will lead towards groundwater recharge, as well as this water can be used for irrigation purpose in the dry period. So next is some comparison between traditional farmhouses and modern farmhouses. So by these two images, we can understand key what are the traditional farmhouses as well as modern, or what are the difference between the traditional farmhouse and a modern farmhouse. There is also a very important aspect, like within the farmstead or within any farm, operational farm, we require huge amount of energy. So energy generation aspects should also be explored at the planning stage itself. Like suppose the area is say like the area throughout the year there is a high speed wind. So we can go for installation of windmills. If it is dry area and for maximum days within a year we get sunlight, so in that case we should go for installation of solar panels. So this type of arrangement should be made to avoid any scarcity of power or energy, because energy is required for each and every step or for each and every process within the farmstead or within the farm, like for chaff cutting, for pumping water, for irrigational activities, as well as for feeding animals. So everywhere several energy or say like machinery has to be used, and for running all those machinery we require energy. So concluding it, planning is the first and most important step in designing a farmstead. Their modern farmstead should provide efficiency, security, and safety. Then a farmstead also is also a place of relaxation, recreation, and play of workers, family members, guests, or others. Some farmsteads will have high demand for electrical power and water supply. The plan should be accordingly to provide efficient distribution of these services. So many times we see that farmhouse, uh, many people they construct or they develop farmhouse not for the say like only for economic benefit, but mostly the people who are residing in cities in a very dense populated area, they choose or they develop such kind of farm in a countryside or in rural area, and they go and stay there for few days, for few months, to relax their body and mind. So a farmstead is also not only a place for agricultural activities only, but also it is a place for relaxation, for recreation, for to play, then for family members, then guests and other activities. Uh, so if our farmstead or farm is for such kind of activities, a huge amount of energy will be required. Like whenever the people are going to stay in that farmstead within that farm area, they will require electricity for cooling, require electricity for cooking food, require energy for making them warm, for refrigeration, light, fans, cooler, AC, several other equipments are there which has to be operated using energy or say like electricity. So for this reason only, At the planning stage only, there should be uh, proper steps has to be taken for installation of energy harvesting devices like windmills, installation of windmills, as well as installation of solar panels, whichever it is suitable in that area. So nowadays we see that there are huge subsidy from the government side for the people related to alternate energy sources. There are huge opportunity, like say like for area like Rajasthan, there is a huge opportunity for installation of uh, solar panels, and government is providing subsidy, and people should avail it. Whenever I travel towards travel on highways, especially traveling towards Delhi, I see a much more number of farmhouses on the highway, which is Jaipur to Delhi highway, and many of them are very well made, constructed, as well as I think all the facilities of energy generation is also there, because we can simply understand that most of the farmhouses are in the rural area, so there are no proper supply of electricity as well as other options are there. So in that case, there is a single option uh, to develop our own energy generating devices, or to install our own energy generating devices, so that there will be no scarcity of power. Animals in the market nowadays, different shape, design, capacity of silos can be very commonly seen, starting from, or the size varying from few kgs to several tons and quantities. So there is a need to store animal fodder and feeds, fertilizers, seeds, vegetables, milk and other milk products. There is also need to store farm machineries, etc. So all these things are stored in a variety of storage structures. Nowadays, when agriculture is commercializing day by day, very commonly we see several warehouses are being constructed, even in rural areas, either by government as well as private sectors, in order to store grain items or food grains. So why there is need of storing either food grains or fodder items? We know that in Indian scenarios, season varies. Three or four different types of seasons we are observing in our country. So there are some fodder crops which can only be cultivated during winter season, and there are some fodder crops which can only be cultivated during rainy or summer season. So during off season, there is non-availability of green fodder. So also, like whenever there is harvesting of cereal crops, the remaining biomass can be chopped or either threshed, and that can be stored. The straw can be stored for feeding the animals. So there is a need to store this fodder or feeding items to be fed to the animals on daily basis. So the structures which are used for storing the fodder are called silos. So silo is a farm structure which stores and preserves the animal fodder in an ideal condition. The fodder is cut and packed in the silo in an airtight condition to favor for partial fermentation. The stored fodder is known as silage. The
Fodder, which is stored inside the silo, is known as silage, and silage can be made from any grain crop with moderately tough stalk. Examples can be grass, sugarcane, leguminous crops, and many more. So here I would like to discuss a bit about silage. So silage in this type of silos, dry as well as green fodder can be stored. So talking about dry fodder, mainly that is a husk or dry biomass or straw, which comes after harvesting and threshing of crops. So we can store all those feeding items or fodder items in the silos. Here we are talking about the green crop. So we know that during off season or during dry season, there is a shortage of green fodder. Dry fodders are available, and green fodder is not available during that season. Therefore, our method has been derived to prepare silage. So for preparation of silage, we take green crop, we chop that crop biomass in small pieces. There is a specific dimension or size recommended. So we chop into small pieces. We mix some chemicals and we store it for at least that can be stored for say like 100 days or 120 days. And if we maintain the proper storage techniques, proper manage, we minimize the water leakage and all. In that case, the quality of silage and the nutritive value of silage increases. And the animals who are fed with a good quality of silage, it has been observed that their milk capacity, lactating period, as well as their body weight is increased compared to the dry feed. So silage is more nutritive than dry stocks, but when compared to green fodder, there is some loss of nutritive value in silage too, because the sugar is converted into lactic acid, giving a sour taste. Losses may also occur due to surface spoilage, fermentation, as well as seepage. So, loading of tower silos is difficult. There are different types of silos: horizontal silos, tower silos, and pit silos. So, tower silos are constructed above the ground. Horizontal silos are also constructed above the ground horizontally. Main problem comes when we construct or when we talk about pit silos, which is under the ground. So we see that silage is very nutritive, but still there are some limitations. When compared to green fodder, there is some loss of nutritive value. So loss may occur due to surface spoilage, fermentation, and seepage. Loading of tower silos is difficult. Why it is difficult? Because it is in the form of towers and the feeding mouth is on the top, so we have to lift up all the feeding materials or fodder items onto the top of the tower silo, then only we can feed it. Or nowadays there are several suction machines or suction pumps, we have to use that all pumps to for storage purpose. So loading of tower silos is very difficult compared to other type of silos like pit silos, horizontal silos. So it needs a mechanical loader or a large capacity blower for elevating the job. So the wall should be smooth, circular and strong enough to avoid cracking due to lateral pressure. Hence a heavy reinforcement is also required while construction of tower silos or any type of silos. The only advantage is if the water table is very close to the ground level, tower silos are preferred. So, if ground level, if the water table is very close to the ground level, in that scenario, tower silos are preferred. Otherwise, we go for pit silos. So, the cost of construction of these silos is comparatively much higher than that of horizontal type as well as pit silos. So, here we can see some of the images of different type of storage structures which are used in India as well as abroad. So the first image is image of first and this down second. These two images are of trench or trench silos. So these are on the ground surface, above the ground surface, and uh, the size is not limited. It is up to the choice of the user or the owner. And in this method, we store the feeding items and we can daily remove and feed the animals. Second one, this green color are example of tower silos. So this one is a very small unit, and this kind of units are for storing large quantity of grains or other crops. So if we move on next slide, we see some modern as well as traditional order storage techniques. So these two are the traditional order storage techniques. Even today in rural India, people use this type of structures because for making this type of structures, machinery is required, whereas mechanization is very low. The standard is very low. The level of mechanization in Indian farms are very low. Additionally, for this type of arrangement, extra monetary input will be there. So, due to several reasons, still in rural part of India, this type of activities are not ongoing. Still, we use the traditional method of storage of grains and fodder. So, next one is horizontal silos. So, horizontal surface silos are used for storing silage. These silos are readily and cheaper made at any time. They can be easily filled and unloaded without any equipment. They are successful in areas having a deep water table. The dry matter losses ranging from 20 to 30% while filling either trench or pit sand. Chopped silos should be spread level and packed. They are filled till the silage reaches about ground level, and they should be covered with dry paddy straw or plastic cover in order to minimize water leakage, especially during so, rainy season. So, so we can see that horizontal silos are very useful, readily available, and cheaper compared to other different types of silos. But still, there are some limitations, like this type of silos can only be preferred or can only be constructed in those areas where water table is very big. Otherwise, there is going to be chances of corrosion as well as uh, loss of the water or dry matter loss. And that dry matter is limited to 20 to 30%. So next one is pit silos. So it is a circular deep well-like structure which is lined all along the side and bottom to prevent the water entering into it. They can be made of bricks or stones or concrete with either lime or cement, but up to a depth of 15 meter to 22 meter. So the depth is limited. it should be vary between 15 to 22.5 meters, not more than that. So wall should be provided with plastering the entire inner surface, and a simple roof over the silo can provide to protect the silage from direct falling of sun as well as rainfall. So generally a cow is fed about 1.4 kg of silage per 45 kg of her body weight. Body. So accordingly, for say like for 100 cows, and weight is uh, say like 80 or approx 80 kg of body weight, so they can be fed 3 kg per day. So diameter of the silo is determined by quantity of silage fed daily, and that quantity of the silos depends on the number of animals. So the rate removal should be at the rate of 10 centimeter per ton or more than that. The diameter is limited to 6 meter and its depth is kept 2 to 3 times of the diameter, not more than that. So talking about design criteria, rate of removal is 10 centimeter per day. Silage fed per day is 3 kg per 100 kg of body weight. Maximum diameter is 6 meter. Depth is 2 to 3 times diameter, so it can be up to 18 meters. And it is assumed that 1 cubic meter of silage equals 650 kg. So now there is a problem. Design an economical diameter and depth of a pit silo to store sufficient quantity of silage for a herd of 300 dairy cows, having an average body weight of 450 kg each. The cows are required to be fed with silage for 200 days per year, and also find the required number of pit silos to be constructed. So there is given in the question itself number of cows 300, body weight 450 kg, and number of days per year which has to be fed. That is 200 days per year. So solution is 1 cubic meter of silage is 650 kg. Rate of silage removal is 10 centimeter per day. Let each cow fill 3 kg of silage per 100 kg of body. So 3 by 100 into 450, it will be 13.5 kg per day for single cow. Then weight of the silage required for 300 cows is 13.5 into 300, that equals 4050 kg per day. So volume of pit for a daily withdrawal depth of 10 centimeter, we can use the formula of uh, calculating area of the circle when diameter is known. So after equating equation number 1 and 2, we get D equals 9.756. That means it is approximate 10 meter. So now the depth of silo is daily depth into number of days, that is 0.1 into 200. So it becomes 20 meter, allowing 20% of loss. Actual volume of silage is 20 plus 4 equals 24. As the diameter of pit silos is limited to 6 meter and depth is limited to 18 meter, not more than that, therefore two silo pits are required to be constructed. So next are trench silos. So I have shown in the image how a trench silo looks like. So trench silo is this one as well as this one. We make canal-like structure on the ground surface, and in between we can store the feeding items. So trench silos can be either or lined one or unlined one. Unlined silo is easy to construct but give more spoilage of silage and caving in of sites during the rain. A lined French silo is advantageous, and the lining can be made with brick, concrete, or cement plaster with reinforcing wire mesh. Then filling, packing and sealing are similar to wet silos. The drainage water should not be allowed to collect near the branch, and so drains should be made around the trench. The cross-section depends on number of animals to be fed, and the length is determined by the number of days the silage is fed in a year. So next there is a problem on trench silos. To design a trench silo for a small farm having 140 million weight, 680 kg, and has to be fed at the rate of 4 kg per 100 kg of its weight. The silage is fed 160 days in a year. So data is already given number of animals 140, weight of each animal 680 kg, then feeding rate 4 kilometer. So feeding rate is 4 kg per 100 kg of body weight. Number of days which is required to be fed is 160. So let's assume few things like let the depth of silo be 2.5 meter, length of feet per day be 15 centimeters, side slope is 1:2. So weight of the silage required per day, that is feeding rate into weight of animals into number of animals as well into number of animals. So it is 4 by 100 into 680 into 40, 140. So it equals 3808 kg per day. Next is volume of silage required per day. So we can calculate the volume that is required per day. Next is volume of silage stored per day. So this is the formula for calculating volume of silage. So now by equating equation number 1 and 2 by the same formula, we get bottom width of 14.37, top width of W plus D, that is equal to 16.87 meter, and length of the silo given per year with 20% loss of length. So result will be top width silo 16.8 centimeter, 8 meter, bottom width of silo 14.37, length of silos 24, length of silos, depth of silos 28 meters.